For the last part of this course, we will be discussing what we'll refer to as parasites. Generally, what we're talking about here are mostly multicellular, but some unicellular. They're all eukaryotic organisms, and they all will depend on the host for nutrients and things like that. They are not fungi because they won't have that cell wall made of chitin. So that's basically what we're talking about. Lots of different groups will fall under the category of parasites. Why is studying parasitology important? Well, because worldwide parasitic infections affect millions and millions and millions and millions of people, hundreds of millions of people. They may not be common infections that we see in the US, but we can't be so myopic that we're only looking at diseases in the US when we have so many of these types of infections worldwide, but we also do have some of these relatively close to home as well. We will talk about a number of these different parasitic infections as we progress through this last section. The taxonomy of parasites changes literally every time I try to prepare this section for the class. So I'm kind of to the point where I just throw up my hands and I give up, and I will talk about them like I remember talking about them, like I know them. And as we're talking about these different groups, I will give you the classification that I know of, and you'll just have to trust me and be okay with the fact that the taxonomy itself may not be the most up-to-date, but the organisms are. The first group that we'll end up talking about are going to be what are called protozoa. These are generally unicellular. They are eukaryotic organisms. And oftentimes we talk about them either how they move mostly how they move, or I guess how they don't move, and the ones that don't move kind of get put together. So we have amoeba, we have ciliates, we have sporozoa. The amoeba move by what are called pseudopods. They can extend part of their cell membrane, as if you know your Greek root, pseudopod, like a false foot. So they can extend part of their membrane and kind of creep along a surface. Ciliates move by cilia. The sporozoa, well, they don't move. So that's why they're in that group. We also will talk about a couple of organisms that move through the use of flagella. So we'll talk about some unicellular eukaryotes that move through flagella. We'll also end up talking about the helminths. Helminth is just a broad term for, I think we would call them worms, right? Not unicellular, multicellular, eukaryotic, relatively long organisms. We have nematodes, which are sometimes called roundworms. We have trematodes, which are sometimes called flatworms. And we have cestodes, which are sometimes called tapeworms. So this is going to be, I always like this section. I think it's interesting. So again, we'll talk about these organisms as we get to those sections. We'll also talk a little bit about arthropods. We have talked about arthropods before in the context of how they transmit disease, but we'll also talk a little bit about arthropods and how they can cause disease symptoms. Arthropods are the largest group of animals. They're complex multicellular organisms. They can cause invasive or superficial disease. And again, we have talked about them previously as how they can serve as vectors of disease, organisms that will transmit disease. But they can serve as intermediate hosts. Some of these parasites we'll talk about have complex life cycles that require them to live inside of an arthropod for at least part of it. And we also have arthropods that can do what's called envenomation. They can Often bite, sometimes sting, and transmit venom, which will result in maybe a hypersensitivity, in an allergy. It can result in anaphylactic shock, cause tissue damage. There are lots of effects from being envenomated. The groups we'll talk about will include the Myriapoda, which are centipedes. They have venom in their claws. There are the Pentastomata, which are tongue worms. These are really gross. They're blood-sucking endoparasites. They will literally take over the tongue of fish. There are crustaceans, which we'll talk about mostly as intermediate hosts for numerous different parasites, which is why you don't usually want to eat undercooked crustaceans. There are the Chelicerata. This was formerly basically the arachnid group, spiders, things like that. They have 4 pairs of legs. They can serve as disease vectors or venomous animals. Scorpions are in this group too, ticks. Okay, so anything that basically has 8 legs and 2 major body parts. Then we have the insects, the insecta. They have wings mostly and antenna, but we call them insects when they have 6 legs, right? 3 pairs of legs and 3 body parts. They'll have a head, a thorax, and an abdomen. They can serve as disease vectors and also as venomous animals. When we're talking about the pathogenicity of parasites, just like with all of the other organisms we've talked about, a lot of the factors associated with if the parasite is going to be able to establish infection and cause disease will include the dose that a patient has been exposed to, especially with some of our unicellular organisms. Was there ingestion or injection of a lot of parasite? Was it 1 or 2? How is the parasite able to get into the body? Can it attach? Can it replicate? What type of cell or tissue damage can it cause? And how can it evade the immune system? So all of those factors work together to cause pathogenicity. Parasites get into the body in a couple of different ways. Most often we think of ingestion or direct penetration. So ingestion is going to be a lot of our unicellular eukaryotes, our roundworms and our tapeworms. Arthropods can transmit some of these. Mosquitoes, ticks, kissing bugs can transmit things like malaria, filarial worms, leishmaniasis, trypanosomes. You can have some parasites that can cross the placenta, so toxoplasma, and there are some that can straight up just burrow in through your skin, so things like hookworms and schistosomes. This table gives a number of different parasites, the disease they cause, and how they can attach to host cells. So adhesion is super important. So a number of different parasites have different adhesive characteristics. Cell and tissue damage is really, really common with parasitic infections. Some of them because they produce toxic products listed in the top half of the table. Some because they directly are causing tissue damage. So a lot of these parasites, especially the helminths, the roundworms, the flatworms, and the tapeworms, get big, and they can block organs. You can have pressure atrophy. Sometimes they'll form like cysts that can cause pressure. They migrate through tissue. So you can have some mechanical tissue damage. And then, of course, immune responses as well. Various immune responses to parasitic diseases are listed here. Anaphylaxis is relatively common, especially with some of our Helminth infections. But you can have everything from cytotoxicity caused by the immune system, immune complex formation, and delayed, which is like Similar to what we see with tuberculosis, it's a cell-mediated response. And there are a number of different mechanisms to evade the immune system: antigenic variation, molecular mimicry, looking like the host, hiding the antigen sites, going intracellular. Intracellular, of course, would not be very common with our helminths, but with some of our unicellular parasites, definitely, and immune suppression. As we talk about the different organisms, we'll talk about how some of them do these specific things, but just overall, you see very similar trends. When an organism is able to cause disease, it needs to be able to adhere, it causes tissue damage, and it can evade the immune system. So these are really important traits for any sort of organism that's going to cause disease in a host.